I'm Mohammad Qasim from Department of Computer Science. Today we will study the 8th unit of our course, Information Technology. The content of this unit include communication attack. The attack which are occurred during the communication or transmission of data like malicious code and application attacks. Let's start our unit. Communication attack. Communication attack target the communication channel between two computers, devices, or user. The main objective is to intercept, alter, disrupt, or steal information while it is being transmitted over a network. A communication attack is an attempt by an attacker to compromise the data or information while it is being transmitted across a network. This includes malicious code attacks, application attacks. Malicious code attacks as the attack in which an attacker uses malicious code or software, we call it malware, or harmful code to inflate or infect, damage, disrupt, steal information from or gain unauthorized access to computer system, network system, or any application software without the user knowledge or consent. Malicious code can spread through infected email attachments, malicious websites, compromised software downloads, removable storage devices like USB drives, or network vulnerabilities. Objective of malicious code attacks are steal sensitive information, damage or delete data from systems, disrupt normal system operation, gain unauthorized access to systems or networks, spy or user activities, encrypt file for ransom, create backdoors for future attacks. Malicious code objects include a broad range of programmed operating system software, computer security threat that exploit various network resources, information system resources, software and physical security, vulnerability are to spread malicious payload to computer systems. Some malicious code objects such as computer viruses and Trojan horses depend upon irresponsible computer user IUs by human being to spread from system to system with any success. Other objects such as worms spread rapidly among vulnerable systems under their own power. The sources of these attacks are modern times have given rise to script KD, the malicious individual who doesn't understand technology behind security vulnerability but download ready to use software or scripts from the internet and use them to launch attack against remote systems. These amateur malicious code developers are usually just experimenting with the new tool they downloaded or attempting to cause problem for one or more enemies. Unfortunately, these objects sometimes spread rapidly and cause problem for internet user in general. Viruses. As with biological viruses, computer viruses have two main functions: propagation and destruction. Offenders who create viruses carefully design code to implement these functions and new and innovative method that they hope escape detection and bypass increasingly sophisticated virus or antivirus technologies. It's fair to say that an arms race has developed between virus writers and antivirus technicians, each hoping to develop technology one step ahead of the other. Viruses have some techniques like propagation techniques, master boot record viruses, file infection viruses, microviruses, platform viruses. Antivirus mechanism takes one of the following actions. If the software can remove the virus, it disinfects the affected files and restore the machine to safe condition. If the software recognizes the virus but doesn't know how to disinfect the files, it may quarantine the files until the user or administrator can examine them manually. If security setting policies do not provide for quarantine or the files exceed a predefined danger threshold, the antivirus package may delete the infected file and attempt to preserve system integrity. Virus technology detection or detecting and eradicating technology rises to meet new threats programmed by malicious developers, new kind of software, antiviruses, new kind of viruses designed to defeat those systems emerge. Four specific type of viruses that use tricky techniques and an attempt to escape detection. First is multi-pirate viruses, stealth viruses, polymorphic viruses, and encrypted viruses. We will discuss these in little more detail. Multi-pirate viruses use more than one propagation technique and an attempt to penetrate systems that defend against only one method or the other. Marja virus discovered in 93 infects critical .com and .exe file, most notably the .com command.com files, by adding 2048 bytes of malicious code to each file. This characteristics qualifies it as a file infector viruses. Two hours, 2 hours after it infects a system, it writes malicious code to the system master boot record, qualifying it as a boot sector virus. Stealth viruses hide themselves by actually tampering the operating system to fool antivirus packages into thinking that everything is functioning normally. A stealth boot sector virus might override the system master boot record with malicious code but then also modify the open operating system file access functionality to cover its tracks. When an antivirus package requests a copy of master boot record, the modified operating system code provided with exactly what the antivirus package expects to see. When the system boots, it reads the infected master boot record and load the viruses into memory. Polymorphic viruses actually modify their own code as they travel from system to system. The virus propagation and destruction techniques remain exactly the same, but the signature of the virus is somewhat different each time it infects a new system. It is the hope of polymorphic virus creator that this constantly changing signature will render signature based antivirus packages useless. However, antivirus says vendors have cracked the code of many polymorphic or polymorphism technique and current versions of antivirus softwares are able to detect known polymorphic viruses. The only concern that remains is that it takes vendor longer to generate the necessary signature file to stop a polymorphic virus and its attacks or tracks, resulting in lengthened period that the virus can run free on the internet. Encrypted viruses there has their own outward appearance. They are actually quite similar to polymorphic viruses. Each infected system has a virus with a different signature. They do not generate these modified signature by changing their code. Instead, they alter the way they are stored on the disk. Encrypted viruses use a very short segment of code known as the virus decryption routine that contains the cryptographic information necessary to load and decrypt the main virus code stored elsewhere on the disk. Each infection utilizes a different cryptographic key, causing the main code to appear completely different on each system. The virus decryption routines often contain informative signatures that render them vulnerable to update antivirus software packages. Hoax viruses as a good time viruses warning that first surfaced on the internet in 90s. The computer virus hoax as a false warning about a non-existent malicious threat, usually spread via email, pop-ups, or social media, designed to create panic and trick recipients into forwarding the message. These fabricated alerts often pressure user to delete legitimate system file or click on links that lead to actual malware. While an actual computer virus is malicious code capable of harming your system or stealing data, or hoax is essentially an urban legend. Viruses include logic bomb, Trojan horses, worms, and active contents, dynamic content on the site. The visitor has created a dilemma for website or web administrators. Delivery of this dynamic content require the use of web application that can place an enormous computational burden on the server and increase demand for them required commitment of large number of resources. To solve this problem, software developer create the concept of active contents. Web programs that are downloaded to user on computers for execution rather than consuming server side resources. These programs utilizing technology like Java applets or ActiveX controls greatly reduce the load of the server and client waiting time. This very technology can pose a major threat to client systems. Users may download active content from an untrusted source and allow it to execute on their systems, creating a significant security vulnerabilities. Countermeasures for these attacks are include defense against malicious code is the use of antivirus filtering software. These packages are primarily signature-based systems designed to detect known viruses running on the system. It's wise to consider implementing antivirus filters in at least three key areas: client system, every workstation or network or end user system should have update antivirus software searching the local file system for malicious code. Second is server systems. Server systems should have similar protections. This is even more critical than protecting client system because a single virus on a common server could quickly spread through an entire networks. Content filtering. The majority of viruses today are exchanged over the internet. It's a wise move to implement on your network content filtering that scan inbound and outbound electronic mail and web traffic for sign of malicious code. Integrity checking software such as Tripwire, an open source version, is available. Scan your file system for unexpected modification and report to you on a periodic basis. Access control should be strictly maintained and enforced to limit the ability of malicious code to damage your data and spread on your network. Java Sandbox provides applet with an isolated environment in which they can run safely without gaining access to critical system resources. ActiveX control signing utilizes a system of digital signature to ensure that the code originated from a trusted source. It is up to the end user to determine whether the authenticated source should be trusted. Distributed DOS toolkit. Trino and Tribal Flood Network (TFN) are two commonly used DDoS toolkits. Hackers compromised third-party system and install Trino TFN client that lie dormant waiting for instruction to begin an attack. When the hacker is satisfied that enough clients are lying in wait, they use Trino or TFN master server to wake up the clients and initiate a coordinated attack against a single destination system or network from many directions. The current version of Trino and TFN allow the master server to initiate many common DOS attacks, including synchronization flood and Smurf attacks from the third-party client machine. Teardrops as another type of attack. The teardrop attack is a member of a subclass of DOS attack known as fragmentation attack, which exploit vulnerability in the fragment resembling function of the TCP/IP protocol stack. System administrator can configure the maximum size allowed for TCP/IP packet that traverse each network that carries them. They usually choose this value based upon the available hardware, quality of service, and typical network traffic parameters to maximize network efficiency and throughput. When a network receives a packet larger than its maximum size or allowable packet size, it breaks up into two or more fragments. These fragments are each assigned a size corresponding to the length of the fragment and an offset corresponding to the starting location of the fragment. DNS poisoning. DNS poisoning works without ever touching the target host. Instead, it exploits vulnerability in the domain name system protocol and attempt to redirect traffic to an alternative server without the knowledge of the target victim or the legitimate user. Application attack is our next topic of this unit, in which various application programs were attacked by attacker through use of some mean of communication tools. Specific technique hackers use to exploit vulnerability left behind by sloppy coding practices. First is buffer overflow. The user cannot enter a value longer than the size of any buffer that will load it. For example, if a 10-letter word is entered in place of 5-letter string variable, or the user cannot enter a user cannot enter an invalid value for a various variable types that will load it, a character and two numeric variables. The user cannot enter a value that will cause the program to operate outside of its specified parameters. For example, an answer to system in form of yes or no, question with maybe, time of check to time of use, issues issue and a timely time vulnerability that occur when a program checks access permission too far in advance for a resource request. Another application attack include rootkit, specialized software packages that have only one purpose: to allow hackers to gain expanded access to a system. Rootkit are freely available on internet and exploit known vulnerability and the various operating system codes. Hackers often obtain access to a standard system user account through the use of a password attack or social engineering attack, and then use a rootkit to increase their access to the root or administrator level resources. Reconnaissance attack. Hackers require solid intelligence to effectively focus their effort against the target most likely to yield the best result. To assess with the targeting, hacker tools developers have created a number of automated tools that perform network reconnaissance. Three of those automated techniques: IP probing, port scanning, and vulnerability scan. IP probing or IP probes are also called IP sweep, are often the first type of network reconnaissance carried out against a target network. Automated tools simply attempt to ping each address in a range. Systems that respond to the ping request are logged for further analysis. Address IP address that do not produce a response are assumed to be unused and are ignored during the attacks. Port scanning is the technique where hackers use port scanner software to probe all the active system on a networks or determine what public services are running on each system. For example, if the hacker want to target a web server, they might run a port scanner to locate any system with a service running port 80, which is our default port for HTTP or web servers. Vulnerability scan. Packages contain a database of known vulnerabilities and probe target systems to locate security flaws. They then produce very attractive reports that detail every vulnerability detected. From that point, it's simply a nature of locating a script that exploit a specific vulnerability and launch an attack against the victim. Dumpster diving, an attacking technique in which attackers search through an organization's discarded trash to find confidential and sensitive information that can be used to compromise security. Dumpster diving is one of the oldest hacker tool and it's still used today against security breaches. The best defense against these attackers is to quite simple: to make them more difficult, purchase shader for key department and encourage employees to use them, or data deletion softwares or data eraser softwares. Keep the trash lockup in a secure area until a garbage collectors arrived. A little common sense goes a long way in this area. Decoy techniques: sleight of hand tricks and use them to lure hackers into a sense of false security. For this, we use two types of techniques: honeypots and pseudo flaws. Content files that appear to be sensitive or and valuable to or run false services like a web servers that appear to be critical to an organization operations. The second is pseudo flaw. False vulnerabilities are apparent loopholes intentionally implanted into a system and an attempt to detect hackers. Thank you for your attention. This concludes our today lectures of Unit 8 Communication Attack. This is a further material you can study from the internet as well. This concludes our today class of malicious code and application attacks of Unit 8. Allah Hafiz.